Let's complete the square of something of the form x squared plus 6x plus 5. Let's say the question just says, factorize this using completing the square. What do you do? Completing the square will always have the form this. So you want to force your expression into this form. So how can we do that? So let's say I'll rewrite it down here. X squared plus 6x plus 5. I will always start by writing bracket x, and then we're going to have something in there, and then we're going to have a number elsewhere. This number in the middle, this number here, is always going to be half of this number. So what's half of positive 6? It's positive 3. We can't just go from x squared plus 6x plus 5 to x plus 3 squared, because if you expand this out, you're going to have a plus 9. So if you know how to expand out these sort of brackets, or you'll know that you'll get a plus 9 and not a plus 5. So how do we go from 9 to 5? We minus 4. Done. Now let's say instead it's an equation. What do you do differently? First things first, first step I would always do is move the 5 to the other side. Then do the exact same thing. Write it as x plus what's half of 6? It's 3. Now we can't just go, again, we can't just go from x squared plus 6x to x plus 3 squared, right? Because yeah, if you expand this out, you're going to get an x squared plus 6x, but you're also going to get a plus 9, right? So realistically, we've just added 9 to the left-hand side. So we just have to do that to the right-hand side by adding 9. So now we will get x plus 3 squared equals 4. Then we'll go square root both sides. And then solve it. So we go x equals plus or minus 2 minus 3. So if you solve for both of the plus and minus, so when it's plus 2, we have 2 minus 3, which is minus 1. And when it's minus 2, we have minus 2 minus 3, which is minus 5. And you've solved it. So you can factor by completing the square, and you can also solve quadratic equations by completing the square. Let's go through some quick examples of just factoring without it being an equation. So again, I'm always going to write this x, and then this here is minus 2. So what's half of minus 2? Always don't forget this minus sign. What's half of minus 2? It's minus 1. Right, I shouldn't write plus there. So now we have said that this thing equals x minus 1 squared, which isn't right? So we have to make this equal to the top line. So when we expand this out, we get an x squared, we get a minus 2x, and then we also get a plus 1, not a plus 2. So how do we get from plus 1 to plus 2? With plus 1. Done. Next example. Right, so we always write out that. So the middle term here is plus 8x. So what's half of plus 8? It's plus 4. Don't forget the squared. Now when we expand this whole thing, we get x squared plus 8x plus 16, because that's 4 squared. So how do we get from 16 to plus 7? We have to minus 9. And we have done it. Last example, slightly trickier because now we have an odd number in the middle. Why does that make it tricky? Well, you'll see in a second. So we have x, and now this number here is always half of the middle number. So what's half of 5? It's 5 on 2. Right? Now, again, we can't just say this top line is equal to the bottom line. We have to add or subtract something here to make it so the top and bottom line equal each other. So when we expand this out, we get an x squared, we get a 5x, and then we also get this term squared. So it's going to be 25 on 4. So how do we get from 25 on 4 to plus 1? So an easier way to do this is, so we have this plus 1 here. So what we have done from here to here is we have added this extra term at the end, because remember, this and this don't equal, right? they differ by a term of 25 on 4. So we just minus 25 on 4. And then we can easily just go x plus 5 on 2 squared. What's 1 minus 25 on 4? So keep in mind 1 is basically the same as 4 on 4. So what's 4 minus 25? It's 21. And we affected it. So now we move to the hardest type of completing the square that you can get, and that's when the a here is not 1. So in this case it's 3. So your goal is to first just try and make this number 1 as quick as you possibly can. So one way we can do that is if we look at this part of the polynomial and if we factor out the 3. Right, so let's do that. So this will equal 3x squared plus 4x plus 7. Now, if we do complete the square with this, we'll get our answer. So 3. Now, what do we always do? We write x plus half of this number. So half of positive 4 is 2. Now, when we expand this, we're going to get a plus 4. But in this bracket here, there is no plus 4. There's a plus 4x, but there's no plus 4 over here. So to fix this, we minus 4. Right, now you can expand the brackets. Minus 12 plus 7. Now minus 12 plus 7, what's that? That's just minus 5. Now, that's for the polynomial sense. If you go to the equation, it's actually somewhat easier. What you can do is just divide everything by 3. So we've got x squared plus 4x plus 7 on 3 equals 0. Now we can do how you would usually do an equation. So you would move the 7 on 3 to the other side. Complete the square on the left-hand side. So this is x plus 2 squared. Now on this side with this, we have added 4 on the left-hand side. We have to do the exact same to the right-hand side. That's how equations work. So since we added 4 to the left-hand side, we have to add 4 to the right-hand side. Now, if we just do this quick calculation, minus 7 on 3 plus 4, and that's basically it. So just remember, if you have anything of the form x squared plus bx plus c, so when this number is specifically 1, your first step should always be to write that. Now, be careful, if this is a minus, this will also be a minus. Your next step will be to figure out what to add or subtract here. So it could be minus some number, or plus some number, we'll call it k, to make these two lines equivalent to each other. You can't just write x plus b on 2 squared. You have to add or subtract something over here to make it equivalent. So now you know basically everything you need to know about completing the square, and hopefully you're a pro.